And
Mhm.
thank you.
Okay, it's recording as well.
Perfect.
Okay, so today we're going to talk about number sense. So we start with the sets and sorting, and we're going to move on with number sense because the connection with each time we're meeting, the topics are kind of building on each other. So for children to understand numbers, they need to understand the rules of creating sets, recognizing sets, and following rules to create sets, right? Because then they will be ready to understand numbers. And because numbers technically a set, a collection, right? It's like infinite number of numbers in this number system that we have. Like you can't keep counting and counting. So it's like it's a big set. And the idea is with the sets and sorting, as they build those skills, they can apply that to understanding numbers and see that numbers are a combination of different numbers. So you're learning like nine, for example, but nine by itself is actually a combination of several numbers like nine ones, three threes, like four and five, so these numbers are also collections of different numbers. And eventually, as they're learning numbers, they will be able to dissect, like decompose and compose numbers by using different numbers, by building their number sense. So that's what we're going to focus on. What do we mean by number sense? How children develop number sense and how that impacts their overall like learning of more complicated math ideas. Okay, I'm gonna go and share my screen real quick. Okay, the presentation's here. Okay, number sense. So let's start with an activity. Again, this is another one of those activities where I told you it's like a low threshold, high ceiling, meaning that low threshold, anyone can notice and share something. High ceiling, like what you notice or share could be really, really complicated. Like that's
Mm.
why it's like hitting the ceiling. Um, so when you look at this image here, a jar on a um, surface, what do you notice? What do you wonder? What are some information that's coming to you?
Well, it is it is probably half empty and it's using half of the space and there are different colors
Mhm.
and perhaps shapes of the same type of candy. Um, yeah, I think it's, and there's also, I wonder about how many there are there, how many
Mhm.
yellow, many orange, how many grape color, or if they look different to other objects. Yeah, I can wonder about different
Yeah, a
things.
lot of things, right? And a lot
Yes.
of things that you notice. And that's the beauty of it. When you show this image to young children too, like to your kids, they will share similar things too because it feels natural, right? Like, oh, it looks like half full or half empty. Or it seems like there are candy. I wonder what do they taste like. So when you ask these questions, the kids n notice the similar things as well. Like, are we gonna eat them? Like, how big are they? What does the tag say? So that's where the low threshold comes in, that anyone can notice anything. So when you're opening math learning activities, these are considered like math talk. We're just talking. So when you're designing like learning experiences, try to open the learning with these kind of activities related to what you're going to be discussing that day with the kids. Okay, now I'll ask you,
It's
if
called
you were to
low,
get, yeah,
sorry to interrupt you, Bilge. So these are called low ceiling.
threshold,
Oh,
low
threshold,
threshold, high
threshold.
ceiling.
Yeah.
Yeah.
Okay.
So
Low
anyone
threshold,
can
high
step
ceiling.
in. There's not a whole lot of like
Exactly.
barrier, knowledge barrier necessarily for them to not be able to share.
Yes.
But the high ceiling comes with they can can notice really complex math ideas. For
Yes.
example, you saying like half full or half empty is like complex because that's measurement. Like you understand the word half, what it means, and understand what full means, what empty means. You know, the low ceiling noticings will be what does the tag say? Low
Mhm.
threshold. like it's not necessarily mathematical, but it's okay because that's the whole point. We're making a discussion. So you open with this and see what the kids are noticing, and then you pull their attention to what you want them to focus on, which is in this case, my focus is I want you to make an estimation.
Mhm.
So then I will say, okay, one of you guys share that how many gummy worms are there? Then actually that's a question that I have too. You can say, like, can we make an estimate? What would be too low for, or what would be too high in terms of the number of gummy worms in the jar? What do you think? Like, it cannot be lower than this from what I'm seeing, and it can be more than that. Like, what are those numbers for you?
Are you asking me?
Yeah. And you do this to kids too. Yeah.
Okay. Mm. I mean, I think you mean okay, so I should make an estimate, right, of how
Yeah.
many are there. Okay, I guess 15.
At least there's 15. What is the most?
The most, I guess, mm, yeah, probably 18. Like
Okay,
yeah.
so you're like 15 to 18 probably. Like that's where you estimate. Okay, let's reveal the information. So
Oh, wow.
there were 25 gummy worms
Wow.
in there. But that
Ah,
was a good estimate because you don't know the size of these, right? How big, how small they are. You don't know the size of the jar. So you're just going off the visual that I have for you.
and I don't see very well. So
So that was a good estimate, actually. Some people said like 50. I was like, okay, you're like really off with that one. But when someone says that, when they say 50, 40, that gives you an idea about their number sense because
Mm.
they don't really understand. They're really off with their estimate because they don't understand what 40 looks like, what 50 looks
Oh, I
like.
see.
Does
Okay.
that make sense? Yours
Yes.
was close because you are sensing that it should be around 20, somewhere
Mhm.
close to 20. It was a little bit more than that, 25. So it
Okay.
shows that you have a good estimate, number sense in a way that you're not saying 10. That would have been too low. Does that
Uh-huh.
make sense?
Yes. Uh-huh. Yeah.
Okay, then it becomes the question comes in. Then I ask you, like my students either, like how many gummy worms are left in the jar? So we figured out there were 25, and
Mm-hmm.
there's some of them outside in the jar. How many left in it? And this is the math problem that you're asking children to solve. So instead of giving them what is 25 minus 8 is, you are structuring this learning experience where they start thinking about the problem without you giving them what the problem is, sharing what they're noticing and wondering. And
Mm-hmm.
you give them a specific question, but not quite what the problem is. So
Mm-hmm.
you understand what there's like making them think about the problem. And
Mm-hmm.
then you actually reveal the actual problem that you're asking them, where they need to make sense of all the
Mm-hmm.
informations provided for them to figure it out.
Mm-hmm. Mm-hmm.
So
I
these kind of activities are also called like three act activities, where in each like a theater, act one, act two, you learn about the characters, you learn about the plot of the story, what
mm-hmm.
happens. So each act reveals some information. Think about these images. I like that too. Each image in each represent in each act. So each
Mm-hmm.
act reveals some information.
Mm-hmm.
And then
That's
this is
beautiful.
the end of it. Like this is the plot ends here. And this is the how we conclude the story sense making by thinking about this question.
Wonderful. So beautifully explained.
And um, so, so let's do a couple. This one always like on Zoom doesn't work really well, but I'm gonna do my best to like maybe this will help. So I'm gonna show you a couple dots and I will ask you briefly, like how many do you see? But I will just show it to you because it doesn't really work well on the Zoom whenever I do this on Zoom. So we'll try it and see. Sometimes people don't see anything. Okay,
Mm,
I'm gonna flash I will quickly move from one slide to another and ask you, how many dots did you see? Okay,
mm,
so keep your eye on the screen.
mhm.
How many dots did you see?
Ay, oof.
Did you
I
see
think there
anything?
were four, no?
Yeah, how do you know it was four?
Well, I saw it so quickly, and I think it's because of my previous experience. I was able to recognize some dots, and I saw two of them together on the upper
Mhm.
line. And maybe I saw another. Did you see my balloons?
The balloons? Does that do balloons? I don't have them.
No, I don't know why. I I uh, I think I saw another dot
Mhm.
in the lower right side. I think I'm just making an association. I am not sure if there was a four.
No, there was four
Oh,
actually.
yeah?
Yeah,
Okay.
so you were correct.
Okay.
But you said a lot of key things in there that it reminded me something that I already know. Probably you're referring to um this structure
Worksheets. Yes, worksheets or
or
yes.
like a die, the
Die.
dots on the die. There were two at the top, two at the bottom. It's
Yeah.
a so and did you count them by one? I just like
No,
show it. Did you
no,
had
no,
to, you
no.
just knew, right? You
I
just
didn't
knew.
count them. Right.
Yeah. So that's called a skill that we all have, including children too. It's called our brain is wired in a way that we can recognize small sets without counting. And
Mm.
that's usually up to five. And that's called subitizing.
Okay.
And in this context, it's called procedural subitizing, that you just know. You don't need to count. I know what it looks like. I just like our brain recognize it like that, like this. And that's perceptual subitizing. And it's really important. This ability comes really handy when children are learning numbers because they don't have to count small sets. Once they understand the numbers, they
Mhm,
can just say, oh, there are three dots on the screen. Like, I don't need to count because my brain perceives them
mhm,
easily.
mhm,
And it's just seeing it. You just know. You don't need to count. And that's why when children actually, when we say how many dots and they say three dots, like avoid, if they're saying the correct response, avoid like, oh, let's count to make sure it is, because that's a skill that they already have. And if that's correct, just move on to the next number. When you're asking them a collection, how many are there kind of questions. So that's the big idea. So let's look at another couple more images and see if we're going to be as quick again. Did you see how many?
No, 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 no. I didn't see. It was too quickly. It was too quickly. I didn't even
I
focus
know
that.
it is like
No,
let me
no,
go
no.
back again.
Sorry. This time I miss it.
No worries, no worries.
Too quickly.
Let's do this again. Ready?
Yeah. Okay.
How
Okay.
many did you see?
Three paragraphs.
Three
Paragraphs. Yes.
paragraphs? Oh, okay. Let me try this again. It should be just dots. Let me pull
Oh,
it again.
dots. Oh, no. I saw three paragraphs. One in blue, one in black, and one in green.
Okay.
I don't know
Let's
what
see.
you
I'm
were
gonna share my
responding.
screen again.
Okay.
Okay. Now I'm gonna show you another um slide that has dots on it.
Ah, I
Okay.
see.
Ready?
Yeah.
How many
Okay.
did you see?
I think I saw three on the left side and then four on the right side. Well, yeah, on my side. Yeah.
So
Three
how
and
many did you see altogether?
altogether seven.
Seven. So you noticed there was like a small group of four with small
Yes.
group of three, and
Yes.
altogether there was seven. So
Yes.
isn't that interesting now? Like I told you, subitizing, perceptual subitizing, you can do up to five. You can
Yeah.
just count. But now
Uh,
we have a larger number, seven, and you still was able to figure it out
uh-huh.
by noticing the small sets in the larger number, right?
Uh-huh.
Okay, so let's try another one. where be a bit trickier. Okay, now I'm gonna show you another one. See if you
Mm-hmm.
can notice how many altogether. Ready?
Mm-hmm.
You
Mm.
just-
Okay, that was okay. There were like different groups.
Mm-hmm. Were
So
you able
first
to figure out?
on the upper were two, on the lower there were three, I think five, and then on the right side like two, so seven, I think. I may
It's
have
close.
one.
It's
I may
nine.
have missed one. Eight?
So what was difficult with this one?
Oh,
So you
well,
notice
that's well
couple
spread. Mhm.
sets, but you didn't have enough time to figure it out. But when
Yes,
you have that four and three, you were like, oh, seven.
yeah.
What is the difference? What makes it difficult in here to recognize it? Other than that, there's a larger number.
It is the space that they were spread about in a bigger visual space.
Mm-hmm.
So I have to group them back. Like, I mean, at least for me, it was too quickly to be able
Mm-hmm.
to
To make sense of it, right?
stay on my visual space.
Yeah, exactly. And this is a trick. I'm tricking you on purpose here. So to struggle, like give you a struggle, because it
Yeah.
turns out that like procedural subitizing was like you can recognize small set without counting, right? And you recognize like four. If I have shown you three, you would have recognized it too, even if they were like all over the place, because it's small amount of number, small enough that you can recognize. But when it comes to conceptual subitizing, you need to be able to, you can still subitize large numbers, meaning that you can recognize the total without counting, but it needs to be attached to concepts. The way that you said, oh, they were like, looks like a triangle, looks like a rect square. So there were four dots, there were three dots, seven dots. But when I show you this, it's two all over the place. I don't see a pattern to
Mhm.
recognize, so I can tell you immediately how many. So the conceptual subitizing only works when a collection is organized in a meaningful way. Then we can recognize larger numbers without counting as well. And that's called conceptual subitizing because we're using the concepts we already know to make sense of the a lot of dots in here. Does that help?
Yeah.
Okay.
Mhm.
Um, So, what are some tools that we can use to help children build their number sense? One of them is five frame like this, or 10 frame that looks like this. It's a really plastic and
Mhm.
has like spaces on it. Or you can
Mhm.
just create this on a Word document and print it out and
Mhm.
use that as a 10 frame as well. The other one's Rec and Rec that looks like this, like a abacus kind of thing, and you move the beads from one side to another.
Mhm.
So, like, and these tools we utilize
Mhm.
by relying on children's ability to subitize. So we can use that not ability that they already have to introduce numbers and what numbers represent in terms of quantity. So
Mhm.
let's look at more carefully. For example, five frame that looks like this.
Mhm.
When I show you this five frame, you can see that it helps you organize the representations, which are dots in this case, in a meaningful way that I can see immediately without counting. There are four red dots and one blue dot. It's
Mhm.
not all over the place that I'm asking you how many.
Mhm.
I'm organizing the information in a way that makes you tap into your subitizing skill to figure out how many and what
Mhm.
five looks like.
Hmm.
Five
Mhm.
frames are usually really helpful for pre-K. When you're working with numbers up to five, decompose and compose the number five in various ways. You
Okay.
can have like like three red dots, four and three, two blue dots. that makes 5 too. 3 and 2 makes 5. 4
Okay.
and 1 makes 5. 5 and 0 makes 5. You know, you keep organizing and reorganizing number 5 in various ways by using their ability to subitize and help
Mhm.
them see the smaller numbers in a larger number. In this case, 5 is the larger number. Smaller numbers are 1, 4, like 4, 3, 2, 1, or 0.
Mhm.
Once children have fluency in the 5 frame, in kindergarten, late pre-K and early, like kindergarten, you can introduce the 10 frame. And again, in this one, we are building children understanding of numbers, what
Mhm.
they represent in terms of quantity by relying on their ability to subitize. Because when you like decompose 10 into, if you look at this image, like and like the purple dots and the orange dots, there's like 8 purple dots and 3 orange dots.
Mhm. Mhm.
So I can see by looking at it, if I have fluency up to number 3, like I can see it as like three
Mhm.
orange dots in there. And I
Mhm.
can figure out how many left in the that's for purple dots. And that's because um, 3 less than 10 is like 7. And they can see, oh, this was 5. So that's 2, and this is 5. 5 and 2 makes 7. And 3 and 7 makes 10.
Mhm.
So this provides that before we give them, this is how you write 7, this is how you write 3, we just talk about what 7 is and 3 is and represent those ideas by using these 10 frames and these counters. And we just talk about the numbers this way rather than focusing on writing the numbers. Because as maybe we talked about this earlier too, that we just need to focus on the conceptual understanding before we move on to abstract understanding of numerals, which are the written versions, symbolic representations of the numbers. Because them themselves doesn't tell anything about what that number represent. Writing 10 doesn't mean anything about what 10 really means
Mhm.
in terms of quantity.
Does it have to be on different colors?
So they can see the contrast of
Okay, they need to see the contrast. Mhm.
yeah, so they can see that
Mhm.
there is I can show you real quick. I think in the following
Mhm.
slides I have online manipulatives. This is a website that I like using
Yeah.
with my students. So it has online version of 10 frames.
Mhm.
So if I give you this and I can put this on an iPad, I can put it on a computer, and you can create these with the kids too.
Mhm.
So you can say maybe you roll a die like this
Mhm.
that has dots in them, and you
Yes.
roll it and you have 5. And
Okay.
I'll tell them, show me 5 by
Mhm.
using your 10 frame. And
Mhm.
they can do
Okay.
it like this.
Okay. Mhm.
Or they can make it like this, which is
Exactly.
fine too.
Okay.
Or they can make it like this.
Mhm.
This is all 5.
That's
Um,
5. Yeah.
yeah. And then I can ask them next when they show me 5. Okay. So when you show me, if they're showing me 5 like this, with they're using 10 frame, and I ask them, oh, like by organizing, like showing me 5 like this, what other number, like what 2 numbers that makes 5? Can you see? And they can say, yeah, 3 and 2 makes
Mhm.
5. So
Mhm.
what if we move it like this? Then what 2 numbers make 5? Like 4 and 1. And what
Mhm.
if we move this here?
Mhm.
What two numbers make 5? 5 and 0 makes 5. Does that make sense? So you don't
Yeah.
always have to
Yeah.
like fill it all the way, but you can say 5. And when you're focusing on the combinations of 10,
Mhm.
numbers that combine to 10, then use 2 different colors.
Okay.
Here's like 5 and 5 makes 10, because I want to make it visually distinct for children where they actually use their subitizing skill to see these 2 sets
And they need to use it this type of graphics. So like what you're saying is that these 10 frame
frames.
This is
Hmm.
the diagram that it's suggested to use, because if I just get 10 objects, like maybe from two different colors, it's not going to be the same association.
Yeah,
That's
because remember
okay.
you struggle when dots were all over the place
Yes.
in
Ah,
terms of seeing how
okay,
many.
okay.
So this gives a
Okay.
structure that
Oh,
it's like
wow.
it's organized meaningfully. Now I
Oh,
can
wow.
subitize easily. Does that make
Oh,
sense?
wow. Yes. Oh, my goodness. We are
Yeah.
meeting everywhere in all the schools to do this.
Yeah, I know. And you don't
Wow.
have to like these 10 frames are sold in packages like this in the US.
Okay.
And they come with like multiple like this comes with 20 trays, but you don't
Okay.
have to buy a tray. Like give
Mhm.
like $30 to this. You don't have to do that. You can just literally use your Word document,
Yeah.
create a table with 2 rows and 5 columns, and then just print it out and like, laminate it. And then there you
Exactly.
go. You have your 10 frame. Does that
Exactly.
make sense?
How beautiful. Yes. I'm
So this,
starting tomorrow.
yeah, so this helps them use their subitizing ability to understand larger numbers and decompose them, see that what kind of number combinations make this number without, so they can understand the magnitude of that number, what it really represents. In here, you can also what other combinations can we come up with? What other two numbers makes 10? Let's roll
Mhm.
our die again and
Mhm.
see what two numbers will come up. So you can use those again, these dot ones I like because
Mhm.
it's relies on subitizing, or they can just count if they're not able to subitize. So you roll it, I have 4, and I roll it again, I have 6. Can you
Mhm.
show me 4 and 6 by using um, 10 frame? So
Mhm.
which color will represent 6? I'll use the red, and then you move like this. So 1, 2, 3, 4, 5, 6. Okay,
Mhm.
let's show 4 with yellow.
Mhm.
And then you children keep practicing it this way. So without realizing, they are being exposed to that numbers are a combination of different numbers, and then
Mhm.
6 and 4 makes 10 as
Mhm.
well. 5 and 5 makes 10. And they also see in 4 there are 2 2s, in 6 there are 2 3s. So you keep decomposing, composing, and understanding how numbers are combination of different numbers so they can do those conceptual subitizing by having that fluency, like how different numbers compose larger numbers. The way that you notice with 7, I saw 4 and 3. So
Mhm.
that's what we want to happen with the kids too. When they see a quantity, they can see the combinations that represent that quantity. And that's
Exactly.
how you build number sense. Like they're sensing the numbers, they see the numbers within numbers, kind of,
Wow.
rather than seeing numbers are just like a number that does not
Exactly.
relate,
What is that?
yeah, any other number. Like it's all of them are related to one another.
Oh my goodness.
Does that help?
It's so interesting and simple at the same time. And we
Right?
are just missing so many steps, like so important steps. Go
Mm-hmm.
through all these spreadsheets with numbers, just
Mm-hmm.
numbers. Mhm.
Yeah. Um, I have a video here and that a teacher that talks about how she uses the 5-10 frame. Watch it in your own time. Maybe watch it with your teachers as well. We'll just skip
Yeah.
this one
Yes.
for our purposes, but there's a resource available for you there. I'm just gonna skip it for now.
Thank you,
The
Violet.
other tool is Rec and Rec, and this is like once children build their um, understanding with 5 frame, 10 frame, then you move on to Rec and Rec if it's available. And this because it's a larger number. Like it's 20 beads in here. Like 10 of those are red, 10 of those are yellow. I mean, white. And
Mhm.
again, this structure also relies on children's ability to sympathize, and it mimics the structure for 10 frame. So because you see this is 5, This is 5. I can just see it. It's 5 because it's how it's organized. And this is 5. This is 5. And it's like 20 altogether. And then when you can do the roll die again, I have like 3. Okay, show me 3 with your reckon rack. Okay, 3 here. Roll it again. I have 2. Okay, I brought it in here. So how many you have over this side? 5. 2, 3, and 2 makes 5. How many left on this side? So we started with 20. If you moved like 5 of them on this side, how many left on this side? So
Mm.
when children can count them if they're not able to, but they can also utilize the visual clues like, I know all of these whites represent 5. This is 5. So that makes it 10. This is
Mm.
2. This is 3. That's 5. 10 plus 5, 15.
Mhm.
How these instruments are organized really relies on kids' ability to sympathize to so they can make sense of larger numbers
Mhm.
as they build fluency with numbers.
Wow. Mhm.
Um, so this is a video that a teacher talks about how she uses Rec and Rec in the classroom. Again, feel free to watch this in your
Yeah,
own time as well
of course.
to familiarize yourself. And then the resources that I'm going to share with you, there's like a PDF document that talks about how you can use Rec and Rec in different grade levels. So
Oh, wonderful.
I'll send you that information as well. For pre-K and kindergarten, to build on children's like subitizing skills, I love using subitizing cards with them like this. And this is like, again, a PDF document you download and you cut it out, and then you have these cards like this. And this is a hyperlink that will take you to those cards as well. And I
Mm.
like playing with these because it's again quantity, understanding what these dots represent, what
Mm.
number, and it relies on students' ability to symbolize in a meaningful way and counting in a meaningful way, in a fun way, without like me teaching it necessarily.
Mm.
So these deck of cards, you can design it up to 20 or up to 10, up to 5, depending on the age group of the kids, and print it out and cut it out. And you can give them these deck of cards and ask them to play in different rules by using different rules. So for example, you can get half of the cards, I can get half of the cards, and we can each turn a card, and
Mhm.
whoever has the biggest number can take all the cards. For example, that could be one rule. So in here, we have one, no one takes the cards, and then we'll turn another card. This is like 2, 2, no one gets the cards. Okay, we move on again. The
Mhm.
next one is like 2 and 4. So
Mhm.
the person who had the 4 can take all the cards. And that
Mhm.
could be one of the rules, like where it's encouraging kids to utilize their subitizing skill and work with numbers without necessarily we're doing any kind of like worksheet or anything. They just keep thinking
That
about numbers in a
yes,
fun way.
wonderful. Until how old would you usually do this? Until kindergarten,
So,
like 5 to 6 years old, or how old?
so I will do with pre-K, I will do up to 5. With
Mm-hmm.
kindergarten, I will do up to 10. And I will do up to 20 with first grade.
Okay. Okay. Wonderful. And then you
And
keep.
this,
Mm-hmm.
yeah, and then with this hyperlink, it takes you to that the PDF document. And in
Mm-hmm.
there are different game suggestions. This is one suggestion.
Fantastic. Thank you. Mm-hmm.
Yeah, so you can come up with different rules in terms of how you play. The other one could be a matching game too, where you can put all these cards on the table facing down, and each person can just have a one-time chance to, if you have the same numbers, then you take those cards, and you
So
go
one
again.
one card has the dots and the other one has the number, right? The
None of
written
them has
number.
actual numbers,
Ah,
so it's
no, so it's just
always subitizing. That was a stick. I'll show you.
okay. So if okay, so the two you will find two cards like for example with okay. Let me see.
Okay,
Okay.
hold on, hold on. Let me pull
Yeah.
that real
Mhm.
quick. the subitizing card. Do you see my screen? The
Yes,
subitizing. Okay.
yes, of course.
So it will look like this. There are different versions of these numbers. So some of them are dots like this, and
Mm-hmm.
some hand gestures showing the numbers, some like tally marks. And the last one is the numeral. So if when you are introducing this activity, don't have the numerals until you introduce the numerals to kids. Just have the quantity represented instead, like these dots. And then you can have 10 frame on them too.
Okay, so if you put the cards with the dots and you are playing memory, they just play to find another card with 5 dots. If they open one card that has 5 dots, then just find another card with 5 dots, but never the number. And same with the hands.
So only match the quantity. What is
Okay,
hand
the
and dot,
quantity.
that's okay too. The quantity needs to match.
That's what
And
we
that's
are
the,
doing. Okay.
yeah, that's the beauty of this card so that they can see that quantity can be represented in different ways by
Oh,
using your
beautiful.
fingers, by using dots, by using
Wow.
telemarks, and finally with numeral
Oh,
as well.
excellent. 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 I love it, Bilge. This is so interesting. I am impressed of how fast we push kids, younger kids into, I mean, how many steps they are missing.
A lot, yeah,
And I think,
unfortunately.
and I think, unfortunately, some schools still think that just doing worksheets is much more advanced, you know? It's
Mm-hmm.
sad. Okay,
Yeah.
subitize.
So this is another YouTube video. The person who created that PDF document had a video. So I put that video in here too that she talks about subitizing cards and how to use them.
Mm-hmm.
So take a look at this video as well.
Mm-hmm.
Okay, we'll skip it for now. So when you start working with older kids, we
Mm-hmm.
still utilize their ability to like subitize, but in a different way. So with pre-K kindergarten, we've been focusing on, and early first grade, we've been focusing on like 10 frame subitizing cards. Come like first grade though, we start changing it and start using base 10 blocks with them. Have you ever seen these base 10 blocks?
Yes, yes, Candy has them. Uh-huh.
Okay, great. Because these tools also rely on children' ability to subitize, because it's the same concept. When you think about it, I'm gonna show you real quick. So when you see this like one square, that represent 100.
Mm-hmm.
This each stick here, these like sticks represent tens, place
Mm-hmm.
value wise, and the single cubes represents
Mm-hmm.
the ones.
Mm-hmm.
So if you were to, and this is relying on subitizing because when I see one stick, I think of 10. It
Mm-hmm.
represents 10.
Mm-hmm.
Similar to like seeing the dots and conceptual subitizing. Oh, they were organized into four and three, so I know it's seven, right?
Mm-hmm.
How you like recognize like, so we're using these manipulatives to tap into that subitizing skill because when I see these like four towers or sticks, I know that's 40. I don't need to count it. I'm like, because it's small enough.
Mm-hmm.
Four, I can recognize and say 40, and I see three singles, and that's 343.
Mm-hmm.
So when you are introducing two-digit, three-digit numbers where students are asked to do addition and subtraction problems, that's how we first provide the concrete experience to students rather than doing the traditional algorithm with them. So instead of giving them worksheet where we ask them, what is 95 minus 35? We don't start with that.
Mm-hmm.
We first start with concrete experiences. And then we'll get there to traditional algorithm, which is more abstract thinking, once we have enough experiences with these manipulative concrete experiences. So first we give children, introduce them to base 10 blocks and what they represent. And then once they learn that the big square represents the hundreds, the sticks represents the tens, and the single ones are represents the one, then we show them, can you show me would you use these tools
Mm-hmm.
to like show me 17? What will
Mm-hmm.
17 look like if we were to use base 10 blocks? Because
Mm-hmm.
we've been doing that with guess what? 10 frame,
Mm-hmm.
showing what combinations of 10 look like.
Mm-hmm.
Right now, we're going to do that with two-digit numbers, larger numbers, but by using the base 10 blocks. And they will use like one stick to represent 10, for example, for 17, and seven singles. So
Mm-hmm.
one stick and seven singles, which is 10 and 7,
Mm-hmm.
makes 17,
Okay.
right? Or in this case, four sticks and three singles, 43, meaning that 43 is a combination of 40 and 3.
Mm-hmm.
So they're seeing these like larger numbers can also be representative manipulatives, but this time our manipulatives are base 10 blocks.
I see.
Because with this one, we can only up to do up to 10. With this one, we can only do it up to 20. So we need to like still provide these concrete experiences with larger numbers so they
Mm-hmm.
can see the magnitude of that number. And base 10 blocks is one way of doing that. So they can build that again, sensing numbers larger than 20 and see what does that look like concretely in terms of quantity by using the same unit, which in this case is the base 10 blocks. And it also helps them understand place value, ones, tens, hundreds. What do they look like? What do they mean? And
Mm-hmm.
what do they represent? So once children have this concrete experiences, they see that, oh, like 200, for example, in here, 256 is a lot bigger than 43 because look, we have only four sticks in here and three singles, but look at, we have more sticks in here, more singles, and we also have like hundreds. So as a quantity, I understand when it's like hundreds, when something is three digits, it's a lot bigger than something is two digits,
I
such
know.
as 43 versus 256.
Mm-hmm.
Okay, there's a video in here too, again, that, again, I know there's a lot of information, so
Oh,
I
no
have
problem.
video of
I'll be very
everything.
happy to watch them. Thank you so much for adding.
Yeah, there might be just like some ads in there, so that's why like then we're gonna end up watching ads. But take a look at these videos in your own time to better
Yes,
understand what these tools really mean
wonderful.
and how they what they um represent. And I show you this earlier too. These are online manipulatives. I love the Didax virtual manipulatives. They have a lot of great everything that we talked about. They have an online manipulative version of it, including the base 10 blocks. I'm gonna show you. They have the 10 frame. They have the rec and rec. Oh, I guess they don't have the base 10 blocks. Maybe other ones that have it.
Mm-hmm.
So this might have it. This one's the game. Let's see. These have the 10 frames as well. Okay, there you go. This one has base 10 blocks. So this is the online
Mm-hmm.
where you can, hold on. There you go.
Mm.
Do you see this is like
Yeah.
30, 40,
Mm-hmm.
50,
Mm-hmm.
and this is 53, you know?
Mm-hmm. Mm-hmm.
So you can
Mm-hmm.
keep cleaning it like this, and then Even though you might not have these in the classroom, you can always use these online manipulatives to
Yes,
practice with the
exactly.
kids. You can give them the number, now show me 53. And again, it's not like as hands-on, but if the resource is not available, this is at least still better than just jumping into the numerals and doing the traditional algorithm with the kids and comparing like 53 versus 35, which might not come easily to kids. First, start with the concrete representations with base 10 blocks and then move on to drawing the
Mhm.
numbers and what they represent in the quantity, and then finally go with the numerically, this is what it looks like 53, and then do the comparison that way with just using the number symbols.
Wonderful.
So how we can, as you can see, for even though we're talking about pre-K, kindergarten, first grade, and second grade, we keep talking about their subitizing skills in a different way to make sense of numbers. When they're younger, small numbers. When they're older, larger numbers. But the key thing, main idea is having that fluency with their subitizing. So it's really important with the younger group of kids having these like subitizing cards and playing these subitizing games and when they're pre-K, so they can understand what small numbers represent and identify and the quantities without counting them. So utilizing dot cards or matching games, as we mentioned earlier, is a great ways. Using 10 frame as they get older to build that, continue with that. It's dominoes is another way too. Because eventually when they have when they engage in the exhibitizing activities, what they're actually doing is they're building the foundation for addition and multiplication later. Because when they are using the 10 frame and compose, like making like 6 and 4 and say, oh, 6 and 4 makes 10, that's addition. 6 plus 4 equals 10, or 7 plus 3 equals 10. So by decomposing and composing numbers, they're actually engaging this kind of mathematical thinking. Okay. The other one, when we're doing subitizing activities, we also re-emphasize part-whole relationship, which is really important for addition and subtraction as well. That when you are and numbers can be divided into parts, decomposed into smaller parts or smaller quote unquote sets. So again, like 9 can be 4 and 5. 9 is a whole number. 4 and 5 makes 9, or 5 and 5 makes 10. And so subitizing activities also help them see this numbers are a combination of different numbers, and that builds onto that part whole relationship. And this is how it looks like when you're doing the 10 frame. Like 5 and 0 makes 5. 4 and 1 makes 5. 3 and 2 makes 5. 2 and 3 makes 5. 1 and 4 makes 5. And 0 and 5 makes 5. Do you have any questions so far, Maite?
I am so excited learning about it. And if
Mm.
you don't mind, I am going to just do a small picture of both of us here. Is that
Yeah,
okay?
yeah,
So,
yeah. Go for
how
it.
about we make a screen,
Yeah, stop. Was good?
Yeah, did you take it?
No, do you want me to take it? I can
Or,
take it.
yeah,
Let's see. There you go. Ready? Okay. Ready?
yeah.
Okay, I did multiple.
Thank you. Oh, I can do it too. I'm sorry. I thought that it will be with the
Screenshot.
yeah,
I
I
can
don't know
try
how to start.
screenshot too. I'll do a screenshot and
Don't
see
worry.
if I can save it. Ready?
I, okay.
Okay, I did one.
Okay.
Okay.
I'll do one more with my cell phone once you keep showing your slides.
Okay.
Thank you, Vilge.
Okay. Next, let me save this real quick. Okay, let me go back.
Thank you, Vilge. I'm
No
sorry
worries.
to interrupt
So
you.
we talked about one of the big ideas was like children can recognize small sets without counting, and that's called subitizing. And we can utilize that ability to introduce more complex math ideas across different grade levels. The other one is helping children understand that the quantity is an attribute of a set of objects. So what do we mean by that? It means that oftentimes people use numbers in a way as a noun rather than adjective. So people say, how many do you need? For example, they ask you, and you say three. I need three. So that doesn't mean anything. Like you needing three doesn't mean anything in terms of quantity. The numbers only mean something in terms of quantity when they are used as an adjective. Like I need 3 pens. I need 3 eggs. Like by itself, three doesn't mean anything. It's just a noun. It's just a word. It
Mhm.
only has meaning when that number represents something. And that's
Okay.
why numbers are attributes, like anything else, like color, shape, as an attribute of something. Like in this case, lemons, they're yellow. They're like round shape, right? There are also four of them. There are four lemons. So
Okay.
one thing that we need to keep practicing as educators when we're introducing numbers to kids, we introduce them as adjectives rather than nouns, where they represent a quantity. So that's why, for example, when you ask, oh, how many chips do I have? Am I holding in my hand? If they say
Mhm.
three, don't accept that response. So how many do I have? How many chips do I have? And you say 3 chips.
Mhm.
Because three
Yeah,
by itself doesn't represent quantity, it's just a number name.
I see.
3 chips represents a quantity.
Yeah, you really want them to make them sense of what they are saying, what they are feeling, what they are sensing. So it's not
Mhm.
just pattern memory or like, yeah, using fingers and that's it, no?
Yeah. Always use numbers to represent something, whether it's a quantity, like concrete objects or ideas, whatever that is, it has to be
Mhm.
used in that way. Um, okay. So those are the, again, big ideas
Mhm.
that's numbers represent quantity and needs to be used that way. And we are able to recognize small sets without counting. And we
Mhm.
need to utilize that ability to make sense of larger numbers, basically. Um, so let's look at this video. In this video, this is a multi-language learner. English is not their first language. And there's an activity where they're asked to do this number activity. So let's look at the child and then talk about what their understanding of numbers. Okay, let me pull the video.
Can you put some on your mat to be the same number? You can take them out of here. Do we have the same number on our mats? They the same? How do you know?
1, 2, 3, 4, 5.
You have 5? What do I have?
1, 2, 3, 4.
Is it the same? I'm going to put mine in a line just like yours. Do you think our lines look the same?
Have to. 1, 2,
Are our lines the same? One. Oh. Now we are the same? How much more is 11 than 5? Do you know how you could figure that out? How would you do it? Your line of blocks is longer, right?
And longer.
Yours is longer.
This big.
Mine isn't so big, right?
Yeah, you big. I'm two.
Okay.
Hmm.
What are your thoughts about this video?
You know, it makes much more sense how difficult can be for children to just count without sensing, no? Like he was
Mhm.
able to understand the problem by sensing, by seeing his line. Probably he was processing, no? At the end, I don't think
Mhm.
he asked at the end. He was really thinking about that, no?
Mhm.
Mhm.
Yeah, I agree.
He was thinking, and I think it's just that perception, well, like it says, no, perceptual subitizing.
Mhm.
I mean, you can see things there, but you don't
Mhm.
know it until you are sensing, no, and you are using
Yeah,
your hands on your eyes to make these groups and understand. Plus, if
yeah.
you had
So
that, probably, yeah, tell me.
So he was with this larger group. He
Mhm.
noticed that like he didn't have, and again there could be a lot of barriers in here because English is not their first language and they're being asked about are they the same, are they the different? So his understanding of same or different might
Ah,
be different too. So
I
we
mean,
really need to be careful, especially when
mhm.
we are teaching in one language and
Okay,
when the students' primary language might not be that language and are they not answering because they're not really understanding or is it mathematical really that they don't understand these
right.
math concepts? So there's this tricky part in
The
here.
language.
Yeah, the
Language
language
is
barrier.
important.
And
I was
because the part, yeah.
I was thinking, sorry to interrupt you. I was also wondering about vision, because the thing is that if you have the things close to you, you are able to count much better. But if the things are further or far away from you, it's much harder to make sense of what you are trying to count. But I'm
Mhm.
sorry, I miss about the language that he wasn't English speaking. It's true the teacher was asking which one is larger. He was saying big, big.
Yeah.
Was
So,
actually he realized it, that his line was bigger. No, it
mhm.
words that the teacher was using wasn't previous to his experience, probably. So it was making it much, much harder, no?
Mhm.
Understand.
Yeah, I agree. And also when he was like a larger collection and comparing, he wasn't to the collection that she had. He noticed that his is bigger and he kept doing like gesturing, like your mine is this big, yours is this big, kind
Mhm.
of. So it gives me an idea. He understand the quantities are not close in terms of the size. So his is bigger, but
Mhm.
doesn't have the number language to attach to that when she asks, how many more do you have than than what I have? He
Mhm.
wasn't able to respond that. Again, it could be math, it could be a language barrier, and similar to when the difference was just one,
Mhm.
he thought they were the same at the beginning, and when she kept pushing it, and then he noticed what's missing, that there's one, but he wasn't able to articulate that necessarily. So in cases like this, then it might be maybe better to go back to smaller numbers rather than jumping into larger numbers to understand
Mhm.
what is their like base knowledge about like understanding small numbers and able to figure out without counting. So he wasn't able to do that with four because when she asked how many, she kept going and counting like this, even though we talked about how children can recognize small sets without counting. But again, is it English thing? Is it math thing? I don't really know. But whenever you have multiple language learners in your classroom or in your school, be mindful about that. That could be one of the roadblocks that the students are experiencing because they're not they because there's research suggesting that whatever the language that we're introduced math as first language, that we're
Mhm.
more comfortable talking about math concepts in that language
Mm.
than any other language. It's
Wow.
just, they say that there's something related to math. It's like, it's really whatever language that we're introduced to wires our brain differently, and then we feel more comfortable thinking about math that way. Like, and this is true for me too. Whenever I need to count big numbers, I count in Turkish. I don't count in English. I just because it doesn't make sense to
Oh
me.
yeah,
Does
it
that
makes much
make
sense.
sense to you?
When I learned CPR in the US, I remember I had to count. So
Hmm.
thinking in numbers and also feeling under the experience of saving or pretending I was saving the lives of someone, I just
Hmm.
couldn't start counting in English. I was counting in Spanish.
Exactly. Because it's something so a basic or like
Oh,
wired in us. Like, so our brain feels more comfortable thinking about numerals and quantity in the language that we're learn them more comfortably than any other
wow.
language. So that's why I'm saying that if you have like multiple language in your classroom
Yes.
coming to your school too, be mindful about that too, that if
Yeah.
you can ask these questions in their first language, that'll give you a better understanding of this child's math
Awesome.
understanding.
That's good to know, Bilge. Thank you
Mhm.
for saying that. So interesting.
Yeah.
Mm.
It is really interesting
And
too.
keep
I
that in
agree.
mind. Yes. It's like
Mhm.
love.
Yeah.
You're comfortable talking in your mother language, no? Then
Yep.
thank you for
Or
me, of
argue.
course.
I'm better
Ah,
argue.
yeah.
I in your own like, oh.
Yeah, yeah.
Yeah,
It's some
I
sides of
know.
the brain. Yes.
Yeah.
So
No,
interesting. I love it.
I know. Okay. Hold
At
on.
what time do you have to finish? Don't, I know that we start a little bit later, so let me know when
Oh,
you.
I think like probably by 3:30 we can wrap up. I don't think we have a lot
Okay.
left. We only
Okay.
have a few more slides left.
Okay.
Okay. Let me go back real quick. Okay. So, what are some things that we can do to build number sense starting from early on in later grades? So, with infants and toddlers, if you have like infant toddler classroom, the rule of thumb is really children should feel comfortable being able to recognize numbers up to their age. So
Okay.
with toddlers and infants, you will like two, three the most that you want them to like have. Because you will see you work with infants and toddlers too, that the kids are, and you have infant and toddlers, like you have your children. You know, the kids, how they're like, oh, I'm not a baby. I'm gonna be two. Like I'm gonna be three soon. Look, so they understand that three is bigger than two. I'm like
Yeah.
1.5, or I'm
Yes.
like 2.5, and things like that, right? So they just want to be older. They want to be, and they because I understand that that's more that
Mm-hmm.
comes with
Mm-hmm.
that maturity. Something else comes with too. So the rule of thumb is like don't go beyond that number with the young kids, infants and toddlers. Work on that using songs or rhymes like five monkeys jumping on the bed, kind of like songs help them practice this counting skills, understanding numbers
Yeah.
without necessarily we teach them the number. So you can count the snacks that they have, how many plates you're putting on the table, or whose turn, or how many toys that they can grab
Mm.
in the but whatever. So when so focus on those like more meaningful everyday things. To count is more meaningful with younger kids. When it comes to pre-K and K, it's really, really important that we provide concrete experiences of counting, working with numbers, and see what numbers really represent rather than focusing on the numeral symbolic representations of numbers. I see a lot of times people use number cards. What is this number? What is this number? Where it's actual like written numeral on it. That itself doesn't mean anything. So I tell people if you are dead on using numeral like number cards, have concrete representation underneath, the visual representation of that number in terms of quantity next to that number. So if you are going to use number cards, I'm going to go back a couple. Use things like this, where if you're going to show them 17, have like base 10 blocks like this or 10 frame next to it that represent what that number looks like in terms of
Okay. So
quantity.
you don't
But
show just the number alone. That's what
no,
you're,
that
no,
doesn't
it
mean
doesn't
anything.
mean anything. Exactly.
Exactly.
It's like, what
But
is that?
yeah, nothing. It doesn't mean anything.
Exactly.
So especially pre-KK, give them ample amount of experiences where you give them materials like these that we talked about, the bear counters or Unifix cubes like this, where they have these like sets of cubes that they can take apart.
Mm.
Give them like a lot of them and ask them to just count, make groups, and that they are counting it like this. So they have this like tangible experience with counting and understand that there are six in here. Six looks like this, and two looks like this in terms of quantity. So they understand that four is bigger than two. Look, I have a lot in my hand. So two is a small number compared to four. But do you see any twos in four? Oh yeah, there are two twos in four, you know. So they keep practicing this, understanding numbers with concrete experiences, so they can understand what is the power of that number? What is the magnitude of number? What does that represent? Hands, fingers are great tools too, so they can practice counting with their fingers too. Those are great tools too.
I see. Okay. So using fingers is good. Okay.
Yeah, great. Yeah.
Okay. Good to know.
We call these fingers our natural manipulatives.
Ah,
Yeah,
of course.
they come. Yeah, it's great. And we use it like still like as an adult. You keep track of your ideas
Yes.
like this.
All
It's
the
a great
time.
all the time. Yeah.
All the
Or
time.
people do like this, you know.
Yes.
So when you do pre-KK activities for students to build number sense, provide counting games, activities like these subitizing cards, sorting objects by number. Maybe you can ask them to sort these into groups of six. So
Exactly.
each color, I need six of each color, and they can count and create. You can use visuals like number lines or charts, are great tools too, or matching games. For first grade, using base 10 blocks are really important. So because they need to work with larger numbers in two-digit numbers. So tens and ones are a useful way to organize numbers into different groups. So tens and ones in one group. Another thing is like focusing on joining and separating, where like we can say, oh, I had like seven Unifix cubes, and then I got three more Unifix cubes. How many Unifix cubes that I have now altogether? Like this, and they can count it. They can say it. So that's joining example. Separating is I had like 11 Unifix cubes, and I removed four of them. How many left? And then they can count. So that's separating activity. So you can give them, once they have those experience with smaller numbers, you can give them larger numbers where they can join and separate. And they can do that with the base 10 blocks as well. Skip counting is a great way, so they can see the patterns in numbers. Skip counting by 5, by 10 in first grade is helpful to build that number fluency, like 5, 10, 15, 20, 25, 30, or like 10, 20, 30, 40, 50. So if you're going to do counting, do these kind of counting activities with the kids. Okay. So again, using like these kind of manipulatives, mental math problems, real world scenarios where counting can be used as a way to solve problems, which I showed you at the beginning, where I have a jar of candy and each
Mm.
child, the first grader, will have an experience of a jar of candy or chocolate or gummy bears. Like you use those real life scenarios. Oh, we have like this, we have some candy. Can you help me figure out how many in this
Mhm.
jar? Can you have an estimate? You know, those kind of activities you can
But
do. Yeah.
but what would be the difference in mental math problem solving? So they are not able to use any material like to.
So mental math is like that. So you are talking about it like this. So for example, you can tell them like what I gave you when I asked you estimate. I didn't give you any manipulatives. I asked you, what do you think will be the most? What do you think will be the least amount of what is your range? And that was mental math. So I'm giving you a visual, but I'm not like giving you anything to count
Oh,
necessarily, but you're using your mind, your previous experiences to figure
I
out,
see.
oh, it can't be more than this. I know what 20 looks like. That's mental math.
I see. Okay.
Does
Okay.
that, yeah.
Yes,
So we're just having a conversation by looking at things, but we're not manipulating. We're just
they are not
talking
used.
about them.
I see.
hmm
Perfect. Hmm.
And those are like mental math problem
Perfect.
solving, which you did too
Hmm.
when you were estimating.
Perfect.
Second grade is the same way, but this time you're working with larger numbers. Now you're working with three-digit numbers and try to understand what numbers create three-digit numbers. So there's hundreds, there's like tens, there's ones, place value that they all together create numbers with three digits. So they can decompose 252 into 250 and 2
Mhm.
and practice on place value. So number sense by itself doesn't show up in Common Core standards, but we see them in standards related to numbers and operations and place value, where we see the number sense comes up. And
Mhm.
there are some standards under kindergarten, first grade, and second grade kind of relies on children' ability to understand numbers. In kindergarten, it shows up under counting and cardinality, no number names, counting sequence, and compare numbers. So when we say compare numbers, meaning that 6 and 4, which one is the bigger number? 6, right? Comparing numbers are like that. Which one is more? Which one is less? Under the first grade, understand and apply addition subtraction. And this was where we were talking about what are some ways we can make 10. 6 and 4 is 10. 7 and 3 is 10.
Mm.
And that's like 7 plus 3 equals 10.
Mhm.
Or if I take 3 from 10, it makes 7. So there are the number sense activities that you're doing with these tools
Mm.
build their understanding. These are more complex ideas. But I have some additional links where there are some activity ideas for to build number sense in kindergarten up to second grade. Check these out if you come to this website, for example. Here there are like videos about how to use like dart cards,
Wonderful.
printables, and some additional activity ideas
Wow.
and videos. So come to and how to build number sense at home. Oh, there's Spanish translation too. There you
Ah,
go.
great.
Perfect. So there's some
Wonderful.
homework. So click on these links. It will take you to these resources.
Wonderful. Wow. Wow.
So
Oh,
check this
thank
one
you,
out.
Hilge. This is so complete and organized. So much
Yeah. And the
support.
and the other link talks about how to, like, what are some steps you can take to meet these standards that we mentioned? What are some assessments that you can do? What should be your goal? And For kindergarten, first grade, and up, it goes like this
Oh,
for
wow. So there are
this
assessments that you can use in math. That's
Mhm.
wonderful.
Yeah.
Wow.
So check this one. This is specifically for number
Thank
sense
you.
for
It's very
kindergarten and up.
okay.
So check those on. These are the website that are in here. And lastly, I have some suggestions in terms of what books you can incorporate into your library when you are doing activities related to number sense. There's like this. These are all hyperlinked. It takes you to the books page. So check these out. Like 10 Black Dots. One is a snail, 10 is a crab. Anno's Counting Book. Those are all great books. Another one is Room on the Broom.
Oh,
Is a
she's
good book.
fantastic. She's fantastic. I love her.
Yeah, this one is great too. Um, what else? And I have some picture examples. What are some questions that you can ask as you're reading this book? Keep focusing on the number, quantity, like how many were on the broom before the bird joins, how many are on the broom after the bird joins. So
Wow.
you're emphasizing that joining or like separating when they're leaving the broom and things like that. So keep focus on the quantity.
Mhm.
These are some suggestions. Question. Gonna skip that part. And I have this final video that I want to show you, which is unlike it's in Spanish, so it has English subtitles too. And let's watch this video together, and then let's talk about how this teacher, kindergarten teacher, utilized children's understanding of subitizing and incorporated into this attendance chart that they do every morning. Do you have time? A few more minutes?
Of course,
Okay.
yes.
And then we'll finish with that.
Of course.
Okay. Let me make sure that I share the sound. That's okay.
Vamos a observar nuestro chart. Vamos a observar.
Y sí,
Sí que.
hay 20.
¿Y como tú sabes que hay 20?
Sí. 1, 2, 3, 4.
Como ayer. Pero ¿por qué sabes que hay 20?
Porque hay 10 y 10.
¿Hay 10 y 10?
No hay nadie ausente.
No hay nadie ausente. O sea que los 4 grupos de 5, ¿cómo están? Están como completos, ¿verdad?
Aquí
Vamos,
ya no hay.
vamos a observar. ¿Quién me dice un grupo de 5 que esté completo? Juan José, dime. No solamente menciónamelo. Un grupo completo.
La manzana.
Las manzanas tienen 5. Si las manzanas tienen 5 y están arriba, los duraznos que están abajo, ¿cuántos tienen? 5 también, porque son iguales, ¿verdad? ¿Y tú, Víctor, cuál otro tiene 5?
El kiwi.
El kiwi también tiene 5. Cristal, Víctor dijo que los kiwis tienen 5. Yo me pregunto, si los kiwis tienen 5, los limones, ¿cuántos tendrán?
5.
Y como tú sabes que tienen 5 también,
Limones.
los limones tienen 5. ¿Cómo tú sabes que tienen 5, Mateo? Porque no hay ausentes. Tienes toda la razón, no hay ninguno ahora mismo vacío. Pero mira, ¿cómo yo puedo cambiar el número? Porque ya dijimos que había 20. ¿Cómo se escribe el 20? El 20 se escribe un 2 y un 0. Pero para formar el 20, yo no hago 2 y 0. Yo necesito más para formar el 20. Vamos a ver entonces, Aileen. Si yo quiero decir que hay 20, ¿cuántos hay aquí arriba? ¿Cuántos hay aquí? Aquí hay 5. ¿Cuántos hay aquí? Y 5. ¿Cuántos dijimos que era 5 y 5? 10. Si arriba hay 10, mira, todo esto es 10. ¿Cuántos hay abajo? 10 también. Y mira, 10 y 10 son 20. ¿Ok? Vamos entonces a la persona que le toca la asistencia, que es Victor. Victor, ¿tú me puedes contar para ver si en realidad somos 20? Porque ya lo vimos aquí, pero estamos entonces verificando. Vimos
2, 3, 4, 5, 18, 19.
¿Quién falta contar?
A Víctor.
A Víctor, 19.
20.
20. ¿Y cuántos somos entonces en total?
20.
20.
Mm.
So these how
Wonderful.
she used their understanding of the rec and rec, like grouping or 10 frame structure being
Mhm,
utilized in the attendance chart. And the
mhm.
kids didn't have to count. They just know that's five, that's five, that's five, that's five, that's 10, and that's 10 at the bottom. So that's how you utilize their subitizing to like build their understanding of larger numbers
Wow.
by focusing on smaller sets.
Wow. Did you guys train different? Did you train like several schools, no?
So this is from early math when I used to the early math collaborative. So this group of teachers were part of the grant, the research grant that we had at the time that they received the training
Oh, wow.
from early math collaborative where we then went into the classrooms, videotaped them as they're teaching.
I am
Yeah.
so proud of you, my friend.
Well, I
So,
didn't really do, I was just a research assistant, but I'm utilizing the
wow.
resources. Yeah.
You know, I remember I worked for Jennifer and Jackie. Probably it was the beginning of the research, probably the first part. Remember I
Yeah,
told you?
yeah, yeah. I worked too.
I think it was the
2008, 9 or something. Yeah.
pre-test. It was the
Yeah.
pre-test of the knowledge of the children. I think it was just a pre-test. I had to show them different slides, and
Mm,
with and it was much, much before start everything.
hmm.
Wonderful.
Yeah, so and you can see how children were feeling comfortable recognizing the sets. I kept saying like five, five, because that shows that they're fluent understanding what those numbers are in terms of quantity and then decompose the numbers into smaller sets.
Mhm.
Um, yeah, so I'm also gonna send you additional like resources, some activity ideas that you can use, some additional book ideas too, to incorporate into different grades when it comes to building number sense. Like,
Mhm.
so take a look at them. I know it's a lot of information
No, no,
right
I'm
now,
going to
like dump at you.
study everything. I'm going to study everything before to be ready for our next meeting, my friend.
Hmm. So I'm gonna stop recording real quick